Welcome to Brain Vision.
So this problem is divided into different subparts. So what I will do is I will solve each part separately, and before solving any part, I will give some important points regarding that part, right? So let's start with the first one. So the first thing is we have to find out the line currents, right? So we have to find out the value of line currents in each line, right? So as you can see that the if you look at over here, what I will do is, let's suppose this is the minus terminal, this is plus, this is minus, this is plus, this is minus, and this plus. So as you can see this, the sources are, the magnitude of each source is same, 220 volts, right? And the phase difference is 120 degrees in each, right? So what you can see is the sources are connected in the Y connection, right? Balanced Y connection. It says Y connection, right? Balanced Y. Similarly, if you look at over the load, what you can see is the value of impedance. If you look it over here, what you will found is the impedance in each branch is same, right? So the loads are also connected in balanced Y connection, right? So what I can say that the value of, let's suppose this is the line current, we have to find out the line current, and let's suppose this is IA, this is IB, and this is IC. So as we know that the line current will also be same in the magnitude because both of them in a Y connection, but the phase difference will be 120 degree as in the voltage difference, right? So what I'm saying you can understand by when I will solve it, right? So what I'm saying is, let's suppose we have to find out the value of IA. So the formula for IA can be written as you can see, the value of VA is this, and the impedance is, let's suppose the impedance across A is ZA, right? So what we'll get is IA is equal to VA, right? Let's suppose the phase voltage is VA by the impedance, which is, let's suppose ZY, because the value of the impedance is same in each branch. So what I let is that this is the ZY, right? So the value of IA can be written as this, like VA by ZY, right? And the value of ZY is, if I write the, look at over here, both of them are in the series, right? So for getting the value of ZY, we can simply add both of them, right? So the value will become 10 plus 5J ohm. So this is the value of ZY, and the value of VA, as you can see, is the value of VA is 220 angle 0. So let's put it over here. So what I will get is the value of IA is equal to VA, which is 220 angle 0 by ZA, that is 10 plus 5J ohm, right? So what I'm going to do is I am convert the ZY into the polar form, right? So with the help of calculator, we can easily convert it. So if we will calculate in the polar form, you will get it as 11.18 angle 26.56 degrees, right? So if I put it over here, what we will get is, this is 220 angle 0 by 11.18 angle 26.53 degrees, right? So the final value, if we simplify, you will get the value of IA, which is IA is equal to, the final value of IA will be 19.68 angle minus 26.56 degrees, right? So this is the final value of IA. Now we have to find out the value of IB and IC, and as I already said that the magnitude of IA, this is the important point, magnitude of IA is equal to magnitude of IB is equal to magnitude of IC, right? Because this is the balances, right? And the phase difference must be of 120 degrees, right? So what I can say is the value of IB can be written as IA angle minus 120 degrees, because the VB is lagging by 120 degrees, as you can see over here, right? So if I put the value over here, what I will get is the value will be IA, that is angle minus 26.56, right, minus of 120 degrees. The final value of IB can be written as the value of IB will be 19.68 angle minus 146.56 amperes, right? So this is the value of IB. Similarly, if I will calculate IC, what I will get is the IC can be written as IA angle 120 degrees, right? So let's put the value over here. So what will you get is IA is 19.68 angle minus 26.56 degrees plus 120 degrees in this case, right? Because the IC is leading. As you can see over here, this IC is leading by IA by 120 degrees, right? So you will get the value of IC. The final value of IC can be written as the IC is equal to 19.68 angle 93.44 degrees ampere, right? So this is the final answer of IC, right? Now the second part is the line voltages. We have to find out the line voltage, right? So I'm going to calculate over here. This is our second part, which is line voltages, right? So the as you can see in the circuit, as here it is, this is the Y connection. So in the Y connection, the formula for the line current is, I'm just writing the formula over here. The let's suppose the line voltage, which is line current or line voltages. This is line voltage, right? So line voltages can be written as VL can be written as root 3 times of, let's suppose the phase voltage is VPH, root 3 times of VPH angle 30 degrees, right? So as you will look in the circuit, the value of VPH is given. So let's suppose I am putting the value of VPH of A, that is 220 angle 0. So we can simply get the value of VAB, because if you look it over here, the nomenclature is this is our A, this is our B, and this is our C, right? So the value of VAB can be written as VAB is root 3 and VPH is 220 angle 30 degree, right? Because initial angle is 0. So what I can say is, let's write in the better way. This will be 0 plus 30 degree, right? So what you will get is root 3 times of 220 angle 30 degrees, and the final value will become 381 angle 30 degrees volts, right? So this is the first line current, sorry, line voltage, which is VAB, right? And similarly, if I will find out the VBC, what I can write it as, this is the balanced phase, right? This is the balanced phase. So what I can say is the second important point is, in the balanced condition, the line voltages are same in magnitude, right? VAB is equal to VBC is equal to VCA, right? But the phase difference will be of 120 degrees, right? So let's apply this point. So the value of VBC will become as the value of VBC will be as the magnitude is same. So the magnitude will be 381, and the phase difference is 120 degrees. So if I will write it like this will become something this, right? So the value of VBC will be 381 angle minus 90 degrees. This is our VBC. And finally, if we calculate the value of VCA, so the value of VCA or VAC will become, suppose the value of VCA is, again the magnitude will be same, that will 381, and angle will be 30 degrees plus 120 degrees. So this will become 381 angle 150 degrees. This is the value of VAC or VCA. So final part of this problem is we have to find out the load voltages. I think that this is the simplest part of this problem. We have to find out the load voltages. So this is our load voltages. Load voltages. So as you can see in the circuit, if we go towards the circuit, you can simply see over here. This is the load voltage for this load. Just change it. This is the voltage for this load. Similarly, the second one, this voltage is for second load, and the third one is for this load, right? So we can directly write the value of load voltages. So the load voltage for VAN will be, the first one will be VAN, which is equal to V small an, which is equal to 220 angle 0, or simply write it as VA, right? Or the capital A. This is capital A, right? This is the value of VA. Similarly, the second load, let's suppose this is the VPN. So this will become as VPN, which is equal to 220 angle minus 120 degrees, and you can simply write it as VP, right? The third one is VCN, which is equal to VCN, which will be 220 angle 120 degrees, which can be simply written as VC. So this is the final answer for third one.